All right, 67 through 70. All right, the function graphed on this coordinate grid shows f of x the height of a dropped ball in feet after its xth bounce. So it bounces and bounces and bounces and bounces, okay? On which bounce was the height of the ball 10 feet? Okay, well, I can say the height is 10 feet, and that leads me to the first bounce. So that would be A. Which statement is true about the graphs of exponential functions? Okay, the graphs of exponential functions never exceed the graphs of linear and quadratic functions. Well, that's crazy, because exponential functions can grow exponentially. It doesn't matter. It can go on forever and ever. So A is not an option. The graphs of exponential functions always exceed the graphs of linear and well, not necessarily, because I can have a linear function that goes on just as much. Okay? Oops, I meant to cross that out. So not B. The graphs of exponential functions eventually exceed the graphs of linear functions and quadratic functions. All right, so the word eventually is coming into play. Let's read the last one. The graphs of exponential functions eventually exceed the graphs of linear functions, but not quadratic functions. Well, linear and quadratic can go on the same amount, okay? So it looks like C would be our option. Well, linear functions, quadratic functions, and then exponential functions, these grow a lot faster than the other two. All right, 64. All right, so let's see how we're changing, okay? So it looks like I'm decreasing, okay? It doesn't look like I'm decreasing because this is 200, and then that's like 160. So let's see if we can create fractions, okay? So 800 over 1,000. So division 800 divided by 1,000 gives me 0.8. All right, 640 divided by 800 gives me 0.8. So it looks like it's 0.8 since we're multiplying, right? So 1,000 times 0.8, 800 times 0.8, 640 times 0.8, 512. It would be C, because multiplying is exponential, and this is the rate in which we're multiplying. Okay. All right, 65 and 66. Which explicit formula describes the pattern? Okay. So it looks like I'm multiplying by 6 each time. Okay, so that would be an exponential. So how I start would be 1. So how I start times how I change, and it looks like we're going to use D for our term. So 1 doesn't really do anything, so 6 to the D would be C. All right, how I start, how I change to the X. And how you start is when X is 0. All right, 66. A population of squirrels doubles every year. Initially, there were 5 squirrels. The biologists studying the squirrels created a function model, their population growth. So 5 times 2 to the t, where t is the time in years. And here's the graph. Okay, what is the range of the function? So range is talking about, range is talking about y values. And it looks like we start at 5 squirrels. And we just keep doubling and doubling and doubling. So anything from 5 and beyond. So D says any whole number greater than or equal to 5, which would be our option. Because whole number, we want whole squirrels. We don't want half squirrels. That's nasty. Okay, any whole number greater than or equal to 5.